first thing I'd like to do is to go over the quiz from last week. You should have received that quiz in an email yesterday graded. So I'll just briefly go through these problems. And one thing I'll mention that maybe you should do for the next exam is to look at quiz 1 and 2 and then go to exam 1 and see if there's a relationship between the questions you see on those quizzes versus the questions you see on the exam. I think you're going to see that there's a lot of similarities. So between quiz 3 and 4, I think you should consider that, maybe these questions, different problems obviously with different numbers, but maybe these questions are going to also reappear on the exam. So keep that in mind. So I would do that. I would check quizzes 1 and 2, look at exam 1. You're going to see some similarities, and then do the same thing for these quizzes. So this first question, I wanted to see if you could basically solve the quadratic equation using the first 3 methods shown in class. So by factoring the square root method and then completing the square. Because for certain quadratic equations, some of the methods are easier. So for this first one, if you put all the terms on the left-hand side of the equation, you could factor this quadratic polynomial. And then you get 2 final answers down here. So factoring, that really wasn't much of an issue. The square root method is actually a very simple method, especially if you're given in this form where you have some binomial that's squared and then just some other number. You put that other number on the other side, and then you take the square root of both sides. Now, one thing I saw was an issue is that when you take the square root of 16, you're getting a plus or minus 4, not just a 4. So there were some people who only had one answer here because the plus or minus was missing. So the left-hand side just becomes the binomial, and then it's plus or minus 4, and then you just solve for x. And for this one, you could just get actual values for the 2 solutions. And then for completing the square, again, you're moving everything. You're moving this negative 11 to the other side, having the b term and then squaring that. So I kind of made this one an easy one, or half of 4 is 2, the square 2 is 4. So you get this perfect square on the left. And then it becomes a square root problem, right? And then you just go through the motions to get negative 2 plus or minus 15. So the reason we show you these different methods is that when you go to solve a quadratic equation, if you could tell that you could use one of these, it's going to be a lot quicker than, let's say, doing the quadratic formula. But we still want to make sure you know how to do the quadratic formula, so that was number 2. So you just had to go through them. And the first one I left as negative 5 plus or minus the square root of 5 over 2. And then for the second one, you could actually just get values because you end up getting the square root of 49 underneath the radical. So I will point out there were a lot of mistakes doing b squared minus 4ac. So you have to be careful of the signs, right? So when you do negative 1 squared, you get a positive 1. And then it's negative 4 times 6 times negative 2. All right, so those negative signs cancel, so it absolutely becomes 1 plus 48. And we know we can take the square root of 49 and get 7. So you could actually just get, values for that answer. And I will point out that you could use the quadratic equation to solve any of these problems here in number 1. It's just, for the second one specifically, you'd have to square this binomial and then rearrange everything and then do the quadratic formula, where it was much easier just to do the square root method in that case. All right. So you have your 4 methods of solving a quadratic equation. Guaranteed, most likely on exam 2, you're going to have to also know how to do all 4 methods. So just be fair warned. All right, so that was section 1.4, I believe, that material. Now, numbers 3, 4, and 5 were from section 1.5. So number 3 was just performing the mathematical operations on complex numbers. I included some, square root of negative numbers in here because I wanted to check to see if everyone was, okay with doing that. I did see a lot of errors, like I had some people, more than one, change the square root of negative 9 to 1 over the square root of 9, which is not what that is, right? The square root of negative 9, right? You take out the negative 1, right? Because you could split the square root of negative 9 into the square root of 9 times the square root of negative 1. So then you just basically take the square root of 9, which is 3, and since you're left with the square root of negative 1, that's what I is. So what I did in this first one is I changed the square root of negative 4 into 2i, and then just did the subtraction. Some issues I've seen here is this negative sign here has to be applied to both terms here. So a lot of people did negative 2i plus 6i and had a 4i here, but you have to subtract. So you're basically distributing a negative 1 here in this second binomial. Weren't many issues with this second one. Again, it was just FOIL. And then having this I squared term changes the 6 into a negative 6. And then again, distributing here and then knowing that the I squared here is going to make that a negative 15. And then number 4 was basically getting rid of the complex term in the denominator. So we're really rationalizing the denominator just like we did in one of the previous sections. So what we have to do here is find the complex conjugate, which is just the same binomial or in the denominator, but change the sign. So you multiply both the numerator and the denominator by 3 plus I, you'd get this. Now what happens in the denominator is you get an I squared. So 9 minus an I squared, so that's like saying 9 minus a minus 1, which is 9 plus 1. So you get a 10 down here. Now it's hard to see because I crossed some things out, but you have 15 plus 5i over 10. So basically you could divide everything by 5 and be left with 3 plus I over 2. So I accepted that. Or if you just put it in standard form like I had asked, it's 3 halves plus 1 half I. Okay, so for number 5, this was solving a quadratic equation that's going to have a complex solution. Now I was hoping you would see that doesn't it look just like the square root method? Like the setup of number 5 looks the same way where you have a binomial squared and then a number. So if you were to move that negative 25 over and then go ahead and do the square root method, take square root of both sides, you would just get x minus 4 plus or minus the square root of negative 25. And we know the square root of negative 25 is 5i. And then the solution is simple, 4 plus or minus 5i. So I saw a lot of errors in this last one here. So again, when you see a problem where you have to solve a quadratic equation, you're trying to identify the simplest method to try to get you to the correct answer. Okay? I saw 2 people come in. Tika's here. Who else just came in recently? What was your name?
Brendan.
Brendan Spellman, right? Okay. Perfect. Okay. So any questions on this quiz? Okay. Great. I'd like to take any questions you now have on the homework. Yes. 23. All right. Hold on one second because I have to detach this and then plug her back in. I'm just going to lose it up there for a second. Make sure that comes back. You good? Awesome. Okay, what was the number? I'm sorry. 23 in section 1.5. 23. Okay. So again, I'm going to have this at the end of the section 1.5 notes. So let's see. 23, we have 6x minus 7 over x. So we have rational expressions. That's the one, right? Okay, so this is a good review because I had some questions over email about these being the most difficult, the more difficult ones in this section. So here's all you have to do in these problems. This is my suggestion, at least. All you're going to do is take all the denominators, right? So like this 5 over here is a denominator of 1, so we can kind of ignore the 1. And all you do is I'm going to make a term over here that's just the product of all the denominators. So I'm going to take the first x that's over there times x squared, right? That's the product of all the denominators that aren't 1. So what I'm going to do with that is I'm now going to multiply. So really x times x squared is x cubed, right? So I could just write that x cubed. I'm going to multiply every term in the equation by x cubed. So let's just see what happens. So we're going to have x cubed times 6x minus 7 over x minus x cubed over x squared equals 5x cubed. At this point, you should be able to get rid of the fractions by canceling out terms. So in this first one, I could take the x out of the denominator, and there's a 1 that's left over, and then I only have x squared in the numerator. In the second term, I get rid of the x squareds on the bottom, and I'm just left with an x in the numerator. And then I can't do anything else with the 5x cubed. All right, now I'll write another line here just to show you what's left over, because that's the first step in these problems, is to get rid of these fractions. So there we go. So now we have to distribute some stuff out. 6x cubed minus 7x squared minus x equals 5x cubed. And now let's get everything on one side of the equation. So I'm going to take that 5x cubed and bring it over to the left-hand side. So it's 6x cubed minus 5x cubed, so I have x cubed minus 7x squared minus x equals 0. All right, so I'm going to want to solve this. Now, what's your first step here? Every time you see an equation, a polynomial, what do you want to look for first? GCF, especially if it's not a quadratic, right? Clearly, right now, this isn't a quadratic. So the GCF for this one is just x, right? So we take out an x. We're left with x squared minus 7x minus 1 equals 0. Okay. Okay, now, first off, you know when we factored polynomials when we're solving a quadratic equation, you set the terms equal to 0. Now, if I say x equals 0 in this case, could that possibly be a solution to this equation? Like the original equation up here. Just look at it. See how there's that x in the denominator by itself in that first term, right? What would happen if I plugged in a 0? I'd get undefined, right? Does that make sense? I'd get undefined. So this is not a solution. So we can ignore that x that's leading out in the front. But now we have this quadratic. Now to me, when I look at this, that thing's not factorable, right? Because there's no way with this c term of a 1, I'm going to get a 7 in the middle. So I have to, and you could always just go right to the quadratic formula if you want, if you get good at it. Right, there's our a, b, and c. So then if we want to use the quadratic, so negative b is going to give me a 7 there, so plus or minus. Now when I do negative 7 squared, I get 49. And then minus 4ac over 2a. All right. What do we get in here? So this is going to be 49 plus 4. So that's the square root of 53 over 2. 53, is there any way to even, I don't think, is 53 a prime number? I don't think anything goes into 53, right? So I think that's it. I think that's your final answer. Okay, does that make sense? Yep, sure. So again, I could have done this a little simpler, but again, the less you have to think about all the steps, the better. You could have used something called the lowest common denominator, or least common denominator, which would in this case just be x squared, right? But if you just get into the process when you want to solve these problems, just this works for all of them. Find the denominators. Here's my x and my x squared. Multiply them together. So then here's that term I multiply, and you'll see that it gets rid of everything, and you just solve it. Okay? Any other questions on this section? John? 39. 39, sure. So 39 is the square root of x minus 1 equals negative 2. Okay. So let me ask you this first, the whole class. If I take the square root of some number, could the result be negative 2? Maybe, right? I don't know. Let's see. Let's see what happens with this problem. So this is a problem where we're going to want to square both sides, right, to get rid of the square root. So when we do that, we're going to have x minus 1 equals negative 2 squared. So x minus 1 equals 4, right? And then x equals 5. All right, so it seems like we have x equals 5. But remember, in these problems where you're working with square roots in equations, you have to check to see if that answer is truly a solution, okay? So here we go. I'm going to plug in a 5 for x, and we get the square root of 4 is negative 2, and we get 2 equals 2, which is not, they're not equivalent, right? So that means the solution to this problem is I don't know if the book probably used this symbol, and we're going to use this in the next section too. It's called the empty set. And all this means is that there's no solution to the problem. Okay. I believe, did we call that an inconsistent equation? Remember? When we had just regular linear equations and we solved for x and we got like something like 10 equals negative 5, right? And we said, oh, okay, well, no value of x gives that solution, right? Or makes that equation actually an equation. So we would just say it's an inconsistent equation. So that's essentially what's happening here, okay? But remember, anytime you get a problem where you have a square root, you always have to check that answer, all right? Now, if it came out to be 2 equals 2 or something, then we know 5 is a solution. But since it's an inconsistent equation, we just say the solution is the empty set. So like a 0 with a strike through it symbolizes an empty set. Any other questions on this section? Yes, sir. 61. Okay. 61. Oh, here we go. This is a good one. So we have 5x minus 3 to the 2/3 minus 5 equals 4. Okay, so this is an equation with rational exponents. So you got to isolate the rational exponent. So we're going to move that 5 over and get this equation. 5x minus 3, that binomial raised to 2/3 equals 9. So what we want to do is we want to get rid of the 2/3. So I'll just throw this over here. If I had x to the 1/2, right? What would I have to do to get rid of it? I would raise that to the 2, right, which is 2 over 1. You see how the 2's would cancel and you would end up just with an exponent of 1. So what I want to do is I want to raise this to the 3/2, but that means I have to raise this to the 3/2 as well. So by doing this, basically nullifies that exponent, and I'm left with 5x minus 3, and over here is 9 to the 3/2. So what we have to do is we just have to figure out how to basically simplify 9 to the 3/2. So I'll do it over here. So help me out. What kind of root is this going to be? Is it going to be a cube root or a square root? How do you know? Right? You look at the exponent, and the denominator of the exponent tells you what type of root this is. So this is a square root, and it's 9 cubed. Okay? Now, we don't really put the 2 here, right? Because square roots, we assume it's 2. But that's where those two numbers go. So now, let's do this. I could split this into this. The square root of 9 squared times the square root of 9. And that becomes easier, right? Because the square root of 9 squared is 9. And then square root of 9 is 3. So 9 raised to the 3/2 power is 27. So I have 5x minus 3 equals 27. So then 5x equals 30. So then x equals 6. Okay. Any questions on that one? Again, and it's okay to work out this stuff on the side. Because again, the more work you show me, if I can figure out, like say you got to this point, but then accidentally just put this as a 3, but everything else is correct, you're going to get way less off on the problem if I just didn't see that and you went right to, that would have been 9 here. I would have been like, how the heck did they get 9? But if you'd show me the work that you did, I would love to be able to undo what I just did here. Let's see. Let's just see. I think that's it. Beautiful. Okay. Yes, sir.
Would you you not like use like plus or minus 27 or no?
No, you would not. No, not in this one. Anything else in this section? We'll put this one to bed, I think. Because I basically went over every type from this section. Excellent. Okay, so section 1.6. Before we get there, I want to just reiterate those announcements I sent to that email, just in case you haven't seen that email. So we're going to have an exam. We're going to have an exam next Tuesday, October 13th, and it's going to be on sections 1 through 6 in Chapter 1. Sections 1 through 6. And that'll be Tuesday, and you'll be given all class for it. Second announcement in that email was you already have one exam and then 4 quizzes. So I used those grades to calculate what your grade is currently in the course, and then I use that to input midterm grades, which were due Wednesday, but I put them in yesterday. So when you see your midterm grade, I think I just did it for everyone because there's a lot of first-year students, but there's a couple sophomores. I just did it for everyone so you can see where you stand. And if you had a C- or less, I had to indicate what the issue was. So if you did really bad on a test, I indicated that. But if you see a lower grade, don't think that's like where you are now, because there are a lot of people who maybe bombed exam 1 but have shown improvement in the past couple quizzes. So I think, once you get that exam 2 grade in, the exam grade average is going to increase and everything. So don't be too worried about that midterm, but, and everyone will probably know that they're getting a lower midterm grade based upon the quizzes and the exam grades. All right, so there are the 2 announcements. I also wanted to make sure I got that on the video. Okay, so let's move on now to 1.6, which is the last section that's going to be on the exam. And here it is. We were talking about inequality. So let me just quickly review what we finished up on Thursday. So I just went over the inequality symbols. Hopefully they're actually all already in your brain from high school. And then I showed you when we have to put these things on a number line, what that would look like. So if you had the greater thans or less thans, we use parentheses. And the parentheses signify that wherever the parenthesis is on the number line, the solution does not include that particular number. But if we wanted to include that particular number for greater than or equal to or less than or equal to, we use a bracket on the number line. All right. So when we're solving inequalities, I'm going to want to see the solution 2 ways. I'm going to want to see the solution on the number line, and I'm going to want to see the solution in interval notation. So that's why I started introducing interval notation earlier this semester. So let's just quickly go over this first example. So there are 2 rules for solving these. Rule 1 is really not even a rule. It's just you pretend when you're adding and subtracting terms that the inequality symbol is like an equal sign. There's nothing changes with that sign when you do addition and subtraction. But when you're multiplying and dividing, and I gave you this example, negative 2x less than 6, when you divide by negative 2, anytime you divide by a negative number, the inequality symbol flips 180 degrees, right? So if you started with less than, it becomes greater than, and then vice versa. So we did this first example. I gave you, it looks like an equation. It just has an inequality symbol. Our goal is to get down to x on one side and then some number on the other. So we got x is less than 1. So you're going to see we used the parenthesis at the 1 value on the number line. And since it's less than, any number all the way to negative infinity is a solution to this inequality. So the number line solution is obvious. You can see it. And then the interval notation would be, again, we always use parentheses for negative infinity or positive infinity. And then it would just comma up to 1, because that's where we ended on the number line. And we're using a parenthesis again because the parenthesis is what we used on the number line, because we do not want to include 1. All right, these are actually not too bad. Let's do another one. How about this one? Okay, so there it is. So we want to go ahead and manipulate this a little bit. So what am I going to do here? I'm actually going to move the 7x over to the side with the 2x because I want to end up doing a division with the negative number, just so you have that in the notes. So if I move 2x and then the 7x is minus 7x, I get negative 5x on the right. And then I'm going to add 3 to both sides, right? Yeah, and get a negative 2 on the left, right? And now I'm going to divide by negative 5, which means I have to flip the greater than equal to a less than or equal to, and I get 2/5. Okay. All right, so there's my solution in inequality form. Now I want it on the number line. I mentioned it'd be nice if you marked 0. And then for fractions, I would mark then so clearly 2/5 is between 0 and 1. So if you marked 1, that would be good. And then I'm going to mark, and again, you're just eyeballing the fraction areas. The 2/5 is about 0.4, so it's not quite halfway. We'll say that's 2/5. Now, x has to be greater than equal to, right? So we know we're going to use a bracket. So x has to be bigger than 2/5. So I'm going to point the bracket to the right and then fill in, just make the number line a little bit more solid. And we know that's going to go all the way up to positive infinity. So our interval solution is going to be a bracket, 2/5, indicating we are keeping 2/5 as a part of the solution set. And it goes up to positive infinity with a parenthesis. Okay. Not too bad. All right, now, I'm glad we actually did one of those homework problems because I got to bring up inconsistent equations. You can have inconsistent equalities as well. So what happens, what do you do, to describe the solution set? So here's another example. All right, so I'm going to distribute that 5 in this first term. And we're left with 10 minus x less than or equal to 12 minus x. Now you see the x's are going to cancel out and you're left with 10 less than or equal to 12. Okay. Is 10 less than or equal to 12 true? Yeah, right, it is. 10 is less than 12. Right, because it's less than or equal to, so it doesn't have to be equal. So yeah, that's true. So what this means is no matter what x value you plug into this equation, that's always what you're going to get at the end. So this inequality is always true regardless of the value of x. So if I wanted to write this on a number line, maybe I'd mark the 0, but what I'm going to do is I'm shading in the whole thing because it doesn't matter what x value I put in. So my solution is going to go from negative infinity, so open paren negative infinity, all the way up to positive infinity. I could plug in any x value. I could plug in 1,000,000. I can plug in negative 12. Doesn't matter. I'm always going to have a true inequality. So this would be sort of equivalent to an identity if we were talking about equations. Now the other version of we talked about identities and then inconsistency. Here's another inconsistent one. All right, so let's move some stuff around. So we get 5x plus 10 on this side, and then 5x minus 2. You'll see the 5x's are going to cancel, and we get 10 less than negative 2. Okay, so we know that's false, right? 10 less than negative 2 is never going to be true. And again, doesn't matter what x value you plug in here, you're always going to have a false inequality. So when your inequality is false, you don't have a solution. So all we do here is say the solution set is the empty set. So there are no solutions to this inequality. So you might run into those in the homework. And don't worry about just, if you don't remember what to do, go back to the notes, check to see which one's the, all x values in solution, and check to see which ones are the empty set. Yep, so far so good, huh? All right, so I think everyone have a reasonable understanding about how to do these. These aren't too bad. All right, so what we eventually want to do is to combine two inequalities. Okay. So there's two types of combinations. I'll go through an example of one, of the first type, all right? So the first type, is the and I put it in quotes, is the and type of combining inequalities. We also call this the intersection, which has a symbol. It looks like a upside down U. Intersection. So when you're going to try to combine two inequalities to get a final solution set of that combination, is you're going to see two of them. So let me give you the two in this example. And okay. All right, so now we just have to go ahead and solve these. So let's do the one on the left-hand side here. We'll have the right side, I'm going to bring that negative x over and have a 4x, and then subtract 10 over there and get negative 4. So I have x is greater than equal to negative 4. That's one solution to the first inequality. And now I get the other solution. We're going to have 4x on this side, and then 28. So then x is less than or equal to 7. All right. So just like we have been in this section so far, all we did right now, nothing new yet, is just solve those inequalities, get those answers. So what we want to do next is we want to make some number lines. So let's start with, oh, this isn't 4. Sorry, this is a 1. I don't know if anyone noticed that mistake. Let's start with that first solution of negative 1 is less than or equal to x. So that means x is greater than or equal to 1. Let's put it on a number line. Okay. Now, what we want to be able to do is, because we're going to have multiple number lines underneath here, we always want to include 0. We want to include, obviously, the number of interest in our solution. But then we also want to include the number of the solution of the other inequality. So just, you don't have to go crazy. And again, you could just eyeball it, like, all right, here's my positive 7. Okay. And we go ahead and put the solution on the number line. So x has to be greater than or equal to negative 1. So we're going to have a bracket on negative 1. And then we're going to obviously go all the way to positive infinity. Again, still haven't done anything new yet. All right, now right below it, we're going to do x is less than or equal to 7. Now what you're going to try to do the best you can is underneath the first number line, mark the same numbers you did before. So mark the negative 1, mark the 0, mark the 7. and then put the solution on. So x is less than or equal to 7. So now we're going to go to the left on the number line. Okay. So there are the solutions to the individual inequalities. You're trying to find the solution to the combination, the and, right? So here's how an and works. It means intersection, which means you only want to report the solution of where those number lines intersect. So I always like to do this. I see that you're going to start with the solution to the first one. You see how I could draw this vertical line on -1, right? It means everything to the left of that dotted line is not going to be in the solution, right? Because any number less than -1 is not into the solution of the first one. Okay? And then same thing on this side. That should have went through the 7. Oh, God, right? That should have went through that 7. So nothing to the right of +7 is in the solution. But the solution is everything between those two dotted red lines. So the final answer here, I would draw it on another number line. I'm just doing color so you can see that I'm doing something different. And again, I'm going to mark those same numbers. So my solution here is going to be, well, I have to start at -1 with a square bracket to the right. I have a square bracket to the left on the 7. So the final solution here is everything between -1 and 7. So that's the answer in number line form. The answer in interval notation would simply be bracket -1, comma 7, bracket. So that's our final solution here. So that's an and. You look for the intersection of the number lines. And by intersection, I mean these vertical dotted lines. It makes it easier to figure out what the final solution is. So that's the new part here, how to do the and, okay? So the red part is the only thing new here. Are we okay so far? Any questions? Awesome. All right, so let me show you the other type. The other type, so the second type, why do I do that? Is an OR. All right. This is also the union type of combination. So instead of the upside down U, this is a regular U for union. So let me give you the two inequalities, and I made them just simple so we're not sitting here solving them forever. And we're going to do OR. So these are pretty simple to solve. I'll have 3x is greater than 9, so x is greater than 3. That's one of them. And then -2x greater than, what's that, 1 minus 2, so -1. So x is, now I have to flip, right, because I'm dividing by -2. X is less than 1/2. All right, let's put those solutions on number lines. So the process is actually the same for ORs. So x is greater than 3. So remember, you want to include all these numbers. So I'm going to put a 0. I'm going to put the 1/2. And then the 3. So what I'm doing here is x is greater than 3. Now it's greater than, not greater than equal to, so I have to use a parenthesis. So it's everything to the right of 3 up to positive infinity. Now I do x is less than 1/2. I'll just reproduce that same number line with the same numbers. So I'm less than 1/2, so I'm parentheses to the left. All right, so there's my 2. Now let me get back that red color. This is the easier ones to figure out because anything that is shaded on those number lines becomes the solution to the OR. So here's my number line again, reproduced the same way. 0, 1/2, 3. Anything that's shaded in the above two number lines should also be here on the red one. So I have my parenthesis to the right on the 3, and then my parenthesis to the left on the 1/2, and that's all shaded. So that's why it's called union, because you're sort of adding those two solutions together. So if I wanted to write this in interval notation, I'll start with this first part that starts at negative infinity. Wow, it's terrible, infinity. Negative infinity goes up to 1/2, but we have parentheses. And then if you remember, we used that union symbol before. We're going to union that with 3, comma, positive infinity. So there's the solution in the number line form and then also in interval notation. Okay? Pretty good, right? Everything seems a little simpler, maybe. Yeah? Okay. So that's solving ors and ands, specifically dealing with linear type inequalities, where x is only x to the first power, right? We haven't seen an x squared or anything. But there are inequalities where the polynomial, it has a higher order. Let's get a different color going here. So this would be inequalities of higher order. And really, all we mean are quadratics. You know, we're not going to get into crazy like degree 4 or 5 polynomials, nothing like that. But you could see something like this. Okay. So what I'm going to do for this particular example, and again, I'm all about process, because if I can master the process, you could solve these easily. I'm going to give you step by step what to do here. Okay. So step 1 here is to rearrange. And you rearrange just like if this was a quadratic equation. So you get all the terms on one side. So we're going to have x squared, let's see, plus, or it's going to be minus 3x. And then when I bring that 6 over, it'll be 2 minus 6 on negative 4. And then it's not like there's nothing left on the right-hand side. You just are left with a 0. So that should look similar to you, right? If you had a quadratic with an equal sign, instead of the less than being there, it'll just be an equal sign. So it looks very similar. So you rearrange. That's step 1. Step 2 is factor. Now this one's factorable, thankfully, right? We know these first two terms are x. This has to be 4 and 1. And then this is negative, this is positive. Okay? All right, so what we want to do is figure out those x values. So x minus 4 less than 0. So x is less than 4. X plus 1 less than 0. X is less than negative 1. Okay? So we have two inequalities here, but we're really not sure how to get the solution to this. So first thing we're going to do here is on the number line, so that's number 3, is make a number line. And you're going to include those two values you just found when factoring. So I'm going to have negative 1. I'm going to put a 0 there. I just like having the 0 there. And then the positive 4. Okay. Well, just, I don't want to confuse you. Hold on. I'm going to leave the 0 out for a moment. So we have to do something called test points. And we have to choose test points in all the possible intervals that could be our solution. So just, I'll point out to you. You see that there's an interval here, right, from negative infinity to negative 1. There's an interval between negative 1 and 4, and then an interval greater than 4 up to positive infinity. So you have to know how many intervals are possible. I have 3 intervals, okay? So here's what you're going to do in step 4. And this could be the trickiest step. You want to get your test intervals. You want to write them out because we're going to kind of make a table here. So these problems they're not quick, all right? So we know what the test intervals are. We have negative infinity to negative 1. We have negative 1 to 4. And then we have 4 to positive infinity. Okay. You identify those intervals. Now you have to pick test values. These are completely up to you. Okay? What you're going to want to do, though, for the test values is try to pick numbers that are going to be easy, because here's what we're going to do. We're going to end up plugging them in to this equation to see if the result is a positive or negative number. Okay? So for the interval negative infinity to negative 1, I'm probably just going to pick negative 2, right? It's an easy number to deal with. Or I'm not going to pick fractions or anything. So I'm going to pick negative 2. Now for the interval between negative 1 and 4, what's the number you're always going to pick? If you have an interval that includes 0, pick 0, because 0 is really easy to deal with when you're trying to figure this out. So 0 is going to be my value between negative 1 and 4. And then from 4 to infinity, I'm probably just going to pick 5. Okay? Okay? So I put sine of, and then that's the factored product of my quadratic inequality. Now, I'm not looking for the solution of this when I plug in negative 2 or the solution when I'm plugging in 0. This is what my goal is, and I'll just show you what it is for this first one. If I plug in a negative 2 into x minus 4, is the result a positive or negative number? Like if I plug a negative 2 into x minus 4. Anybody? So like if I do negative 2 minus 4, what do I get? Okay, so you get a negative 6, which is a negative number. So here's what I'm going to do. I'm going to put a negative sign here. How about when I plug in a negative 2 into x plus 1? Do I get a negative or positive number? Negative 2 plus 1. Negative. All right. So when you do negative times a negative number, the result is a positive number. Okay? Which means what I'm going to do is so this means any value that I plug in below negative 1, I'm going to get a positive result. So I'm just going to throw in plus signs there to indicate the solution is positive in there, and not that part of the number line. All right, now I just repeat for the other test values. How about 0? Well, 0 minus 4 is going to give me a negative number. 0 plus 1, that gives me a positive number. So negative times positive gives me negative. So between negative 1 and 4, I get negative values. And then lastly for 5 minus 4 gives me positive, and then 5 plus 1 gives me positive. So I get a positive result greater than 4. Okay? So let me just repeat that part of the process. Identify how many intervals you have. This one you have 3. Pick test values that are easy at any place in those intervals. Then you're plugging those values into the factored part of your inequality. And you're not worried about the numerical result. You're wondering if it's positive or negative, just because you want to know if the result's positive or negative. Now, here we go. The final thing is your solution, okay? The most important part now when you're determining solution is this, less than 0. So the only piece that is a solution to this inequality is any place on the number line that has the negative signs. Because think about this. If you plugged in if you plugged in negative 2 into this, right, you would get a number that's positive, which is not less than 0, so it can't be a solution. So the only solution here, and again, I'm going to put it in red, is this part, right in here, right? And we have parentheses because we're just looking at less than. If this was greater than 0, we would have the other intervals as a solution. Does that make sense? So my final solution, if I want, because it's going to want you to put it in interval form, is just -1 to 4 with parentheses. And we're going to do another one of these because, and believe it or not, I don't know if anyone else has to take Math 107 or even calculus at some point. This exact process is used in many calculus analytical processes. So if you have to take Calc or Math 107, you're going to see this kind of process again. So I think that's why we have to do it in this class. So let's do another one. Yeah, oh, this is a good one. This is a good one. All right, here we go. It's going to look nasty, but don't worry. It's really not too bad. Actually, it doesn't look bad at all. All right, so now I have a greater than equal to. So we're going to see possibly some brackets here. Okay. Okie dokie. So here we go. We got a factor, right? It's already rearranged. So when I factor this, I'm going to take out an x because I see a GCF. I have x, and then I have x squared plus 8x plus 15 greater than or equal to 0. I could factor that quadratic. XX, and then 15, I get 5 and 3, and then they're all pluses. Okay? They're all pluses. Okay, so what do we have here? We have x greater than or equal to 0. We have x plus 5 greater than or equal to 0, so that's x is greater than or equal to -5. And then x plus 3 greater than 0. X is greater than or equal to -3. So you see that we have 3 values now to deal with. Okay, 3 values. Okay, so what was the next step? Number line? Right? If you go back up here where you made a number line, now we have to have 3 numbers on it though, not 2. Okay, let's see, we have -5, -3, and 0. Wonderful. Okay, beautiful. Now we're going to figure out our intervals. Our intervals are going to be, somebody give me the intervals. Anybody? Yes, go ahead. Beautiful. All right, so we have 4 intervals now, which means we need 4 test values. And again, you're just trying to pick easy ones. I might do -6 for the first one. Let's see, -4, maybe -1, and then 1. Trying to make it simple. So now I'm looking at x times x plus 5 times x plus 3. Again, I don't care about the numerical result. I care about positive versus negative. So let's see what happens. So x here, this first term, whatever the sign is of the test value, that's going to be negative. How about -6 plus 5? That's negative. And then -6 plus 3 is also negative. So what's the result? Negative times a negative times a negative gives me a negative. Okay? So all here I have negative numbers when I'm less than negative 5. All right, negative 4. So we have negative. Negative 4 plus 5, positive. Negative 4 plus 3, negative. So look at that. Negative times a negative is a positive, times a positive, we get a positive. All right, negative 1, just negative. Negative 1 plus 5 is positive. Negative 1 plus 3, positive. So we're left with negative. I should be filling these in. And then finally a positive 1. Looks like they're all going to be positive. So we have positive. Okay, so which intervals are we going to say is the solution to this inequality? Which intervals are the solution and why? So you got to look here, right? So greater than or equal to 0, does that signify positive or negative? Positive, okay? So that means all the places on the number line where you see plus positive signs, they're the solution. Okay, so here's how I would write this out. Now, because it's greater than equal to, I have to use square brackets. So I'm going to square bracket at negative 5 all the way to negative 3 square bracket, right? Because you see that these are positive. And then I'm going to union it with a bracket at 0, right? Because it's, again, we're doing greater than equal to, and then we're going all the way up to positive infinity. And that's going to be a parenthesis. All right, so you're trying to figure out on the number line what's positive, what's negative. Okay, so far? Yes, sir.
Do you have to like include the brackets when doing like the intervals like in the chart? Like that's how you
Oh, like do this?
like make that bracket.
No, you don't have to.
Like and now we can just use parentheses.
You mean up here? I'm sorry, I don't understand your
No,
question.
like where the intervals, test value, and like the results, that whole part.
Oh, right, because here's the thing. Yes, so the reason I don't have square brackets down here is I don't want you to choose negative 5. I know negative 5 is more likely going to be in the solution. So I have parentheses there so you don't choose those, you know. I mean, if you accidentally wrote it, but then you still did everything, I'm not going to take any points off, you know, as long as you did everything else correctly. But with these types of problems, again, I don't know if you did this a different way, but we're specifically showing you this way. So if you have to take a Math 107 or calculus or whatever, this is how you're going to determine a lot of different things in future mathematics courses. Okay? Wonderful. All right, there's only one other type of problem in this section. Let's change the color again. So this is rational inequalities. I just want to see how many of these I want to do. Yeah, okay. I'm only going to give you one example of these because the one I do will not, it's going to be just like the ones I'm going to assign for homework. So I'm not going to try to overcomplicate this at all. So what does a rational inequality look like? So it could look something like this. So again, all we mean by rational is there's a fraction that's going to be there. So what we're going to want to do is get every term on one side of the equation. Okay. Now what we have to do here is combine that rational expression with that 1. Now that 1 really, remember, is 1 over 1, right? So do you remember how we did this back in, I think it was a P section? Like if this was, remember if you had A over B plus B over C, remember you did A times C plus, hold on, C over D. Remember you did A times D plus B times C over B times D. Remember all that stuff, right? Same thing here. We're going to do that here. So we're going to do 2x plus 5 times 1, which is not, really nothing, minus 1 times x minus 1, and then the product of the denominators is just x minus 1. All right? So you're going to simplify the numerator. You have 2x plus 5 minus x plus 1 all over x minus 1. And then just combine some terms here. You're going to have an x plus 6 over x plus 1 less than or equal to 0. All right? So you're trying to get to this point in these problems where you just have a single rational expression, less than or equal to or greater than whatever, and then 0 on the right-hand side. So here's what you have to do. We're going to go through that same process we did in the previous problems for quadratic inequalities. But we have to also look at values that could make the rational inequality undefined. So this one's a pretty easy one, and the homework problems are not going to be hard. So we know for x plus 6 less than or equal to 0, that means x is less than or equal to negative 6. So we know we have to have negative 6 on our number line. But we also have to have negative 1 on our number line, right? Because a negative 1 would make this thing undefined. So we know that can't be a part of the solution. It can't be. Right? We can't have negative 1 in the solution. Okay? So that's what we're going to put on our number line. So here it is. I'm going to put it on our number line. Let's see. We have negative 6, negative 1, and then 0. Again, I just like having 0 there, but you don't have to have it. This one, it actually maybe helps not to have it. All right, so let's do our intervals. So we have negative infinity to negative 6. And even though I have less than or equal to here, I don't want to put in negative 6 here because I know that's going to be part of it. Then I have negative 6 to negative 1, again, parentheses, and then negative 1 to positive infinity. There are my intervals. Let's get some test vals. Let's see. I'd probably do negative 7, right? I would do probably negative 2, and then I would definitely do 0 from negative 1 to positive infinity. So what we're looking at is x plus 6 over x plus 1. And again, we just want to know, are we getting positives or negatives? So let's see. If I did negative 7 plus 6 in the numerator, I'd get a negative number, and then negative 7 plus 1 in the denominator is negative. So that result is a positive number, right? If you have a negative numerator or a negative denominator, you get a positive result. How about negative 2? In the numerator, I'd get positive, but then negative in the denominator, which gives me a negative result. And then 0 is easy because it's just positive over positive. Because it's 6 over 1. So you get positive. All right. There's our table of test values. Sorry, my computer is going slow. All right, so we want the solution. Again, where are we looking? Right here. Less than or equal to 0. Oh, I didn't put the pluses and minuses in yet. So which interval is the solution if we want it to be less than or equal to 0? What do you think? It's where the negative signs are, right? So here's the solution. Now be careful. Do we want a square bracket on the 6 or a parenthesis? with less than or equal to 0. Do we want a square bracket or a parenthesis? All right, we want a square bracket on the 6. But how about for the -1? Square bracket or parenthesis? Remember, a square bracket indicates you're including that number. Do we want to include -1 here? I don't think we do, right? Because it's going to make the whole thing undefined, and that sucks. So we're just going to have parentheses. So these really make you think, these ones. These are definitely applying more mathematics than just, solving equations. All right, sweet deal. So here is what I got for you now. Just real quick, I just want to make sure people who I have here. Angelo, did he ever come in? Angelo? No? How about Konstantinos? Nope. And Tommy. No, Tommy. Okie dokie. So I'm going to give you a homework assignment here for section 1.6. This is the homework. This is on page 154, 155. All right, again, these are all odd. 19 to 35, 51, 59, 67 to 75. It seems like a lot, but it's really not. 85 to 91, and then 101 to 105. And they're all odd. So really, what is it? 3, 6, 8, 10. Yeah, I mean, there's really not a ton here. So what my plan would be, on Thursday, answer any questions you have for this homework. This homework, you don't have to submit it. All right, it's not a submittable homework on Dropbox. And we'll go over this intensively to make sure everyone's okay. There will not be a quiz on Thursday. No quiz on Thursday, because it's the Thursday before an exam. I will briefly, you know how last time I went through each section and kind of wrote out the main types of problems? I'm going to do that again, okay? But that's not going to take the whole class. So what I'll do is, after I finish going through your exam review, I will start the next section, all right? But that next section will not be on the exam. Any other questions you have for me? Sir? Oh, they are 154 to 155. And if anyone wants to come up and take a picture of these problems, you can. And let's just call it a day, because there's 5 minutes left, and I don't want to start the new stuff and confuse you. So have a great Tuesday. It's nice to be back in the classroom.
Yeah.
You know? Oh.
I have a question.
Sure.
The last problem, why was it x equals 1 instead of x is less than or equal to 1?
Oh, that was just a mistake. Thank you for pointing that out. When are they going to put the heat on down there? You know, my office is freezing in the morning.
I heard Highland was like super bad, like super cold over there.
Like, just
But they had to bring the computer over and like they
there's a whole
program.
there's
It's
a
a
whole
whole big
thing
process.
about it.
Yeah.
But like, I feel like if it's 30 degrees in the morning, I think we should probably at least have the heat on, like, to get the chill out.
Yeah,
You know what I
in
mean?
the
Just like
morning,
if you're at
like-
a house, just get the chill out. You'll need both pages, or if you could just do one big landscape.
Thank
Probably
you.
do this.
Have a
Hey,
good one.
hey, see you later. We'll see you Thursday. Oh, I probably should have stopped that recording.